Welcome to episode 2 of Nexus Digest. This is our monthly recap of content that has been published on Nexus. And we kick off every episode with a discussion with one of our contributors. And this month, we're going to talk to Jim Labonty. Jim is the former global head of automation engineering at Pfizer. And he's brought some great insight via his blogs into manufacturing cybersecurity. So that's what we're going to catch up with Jim today. How you doing, sir? Good to see you.
Yeah, doing pretty well. I'm semi-retired, but still cranking away.
That doesn't sound like a bad thing.
No, it's actually very good. It's very, very
Yeah,
highly recommend it to anyone who gets in, certain age.
absolutely. If you can
Enjoy life.
do it, right?
Absolutely. Don't hesitate.
Yeah.
My advice.
So let's talk a little bit about, let's start with your last blog contribution to Nexus, and we'll link it here in the show notes and in the video. But it focused on data centers and how they are inevitably targeted by cyber attackers, even physical attacks, as we've seen during the conflict in the Middle East. Maybe you could start by explaining kind of that growing relationship and how manufacturing and manufacturing data and data centers are all kind of interlocked there. What's
Yeah,
happening?
yeah. No, it's all this. It's not really new technology. There was always a growing need over my 40 years that I've worked in the manufacturing and industrial space. There's always been a growing desire and need to really capture and leverage all the information and data um, to get obviously business value from it. And so that's only accelerating, right, in recent years, majorly. And of course now we have the AI technology, which makes it even easier to harvest the information from all that data and make sense of it and then use it, right, to an
Sure.
advantage. And that goes, from the military standpoint, right? We see in the Middle East, that goes into manufacturing to, optimize the production process, make it go faster, higher efficiency, less people touching things or transacting data from one system to another. That should be, right? All done automatically between systems. Um, so there is this growing relationship, and you use the keyword interlock, right? There is an interlock between the manufacturers providing safe and secure systems and technology. So that's their responsibility, and
Right.
it's reasonably expected that they provide things that work well and it cannot be adulterated easily, and work for the function they're supposed to perform. That's why you buy them. And of course, that technology produces data. So, like, how much data is like, as an example, I worked at Pfizer. One biotech suite that makes a drug like COVID vaccine, for example. Um, how many sensors, how many process pieces of data are coming out of a suite like that? Thousands, many thousands of sensors. That's a lot of information on a second by
Yeah.
second basis. That data is coming out all the time. And it's used, obviously, in the production process to make the product, and keep it running well. It's, the analogy I'll use is a car. Here's a perfect example of a full self-driving car. You're in it, right? It's producing a lot of data, hundreds, right? There's hundreds of sensors in a self-driving car today.
Sure.
Where's that data going? Some of it's used to obviously keep the car on the road, not hit anything else or hit anybody else around. Um, but it's also going back up, right? It's going back up to a big AI system, better improve the firmware that actual car is running from. So, and that, eventually, not while you're driving, obviously, you eventually download a new firmware and you get a better version of self-driving, smarter, better, misses potholes now, important stuff. Um, so that same kind of efficiencies in manufacturing are happening at
Yeah.
an accelerating rate. And so you would go back to the manufacturers. Manufacturers need to provide safe and reliable systems. Cybersecurity is a big part of that, right? The defenses around it. You have to have reconnaissance, right, of what's happening, and you have to have protection around that. And protection, um, is being a little forward thinking, and how we put things together. And we'll probably get into that a little bit as to what our issues are, challenges are, with
Sure.
security and these environments today. But,
Yeah.
the relationship is a very key one. Manufacturers safe and secure, users install it properly, the technology properly, and then put fences and put other technologies around all that industrial automation that come from the manufacturers, and to protect it well.
Yeah. So there's a somewhat of a shared security responsibility there between the
So
manufacturers, the data centers to protect all that data, and of course, worker safety ultimately down the line. But who's responsible for what in your experience?
yes, so again, worker safety, number one. Number one in
Sure.
manufacturing is safety, 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 and that has to always be the forefront. You always expect people to go into work and be able to go home at the end of the day. And that's a responsibility both of the manufacturers, but for obviously it's the actual firm that's using all the technology. They have to install it properly. They have to verify it's installed properly. They have to operate with it properly. They have to have safeguards, um, around that technology. Um, but again, that technology, if it's being controlled, it's being controlled by a computer. There's a
Right.
brain behind it all, and that brain can be hacked,
Hmm.
which is a problem, a
Right.
major problem, right? And so, around any of these processes, you as the end user of that technology have to do your best within reason. Do your
Yep.
best. You just can't ignore it. And in a lot of places, we're going to get into that, I think, a little bit. Is how old is this technology?
Right.
Really quick rule of thumb: over half, right? Over half of the technology that's used today is outdated, right? It's the end of manufacturer's warranty. It's totally outdated and still being used. And why is that? The life of manufacturing technology, and that's the legacy automation controls as well. Typical life is 20, 30 years. IT technology, 5, 7 years. There's a
Right.
big difference, right? 4 times difference in the life and use of this technology. And some would say, well, just change it out. Well, just change it out.
Not
And
that easy.
this analysis advisor is like, hey, let's just go to the IT model of let's just evergreen everything. Just put new in every 4 or 5 years. I'm like, good God, right? Our our estimate was $2 to $3 billion. I'm like, okay, where's that extra change laying around, right? It's not. It's
Right.
not. And you're not going to be spending $2 or $3 billion every 5 years. Like, good
Plus,
God.
it all works for the most part. I mean, it does what it's supposed to.
You put it all in and you run it and you optimize it for 3 or 4 years, then you're going to go do this again,
Right.
right? I mean, you're creating work, you're creating churn, and it's, yeah. I mean, the goal is it's like a car again. I love cars. I have a beautiful car and I enjoy it. But you want to keep running it. If it's running really well and you're enjoying it, you keep it running,
Sure.
doing its job. Same
Yeah.
thing in automation in manufacturing or in healthcare. It's doing its job. It's doing it well. Why do you want to change it? You don't.
Yeah.
And that's the point. You don't. You want to do it cost effectively. Okay, cost effectively isn't you throw it all out and you put something new in. That's not cost effective.
Hmm.
You need to put some boundaries around it. Uh, we all know this technology from the 80s all the way to like 2010, 30 years. They didn't worry about cybersecurity. They didn't.
No.
They didn't. You only start to see some of that concern in the SCADA systems, at the what's called level 2 in the Purdue model, that are running real time, not real time operating systems. They're running a general purpose operating system like Microsoft, Windows technology or a
Right.
based, a Unix based
Hmm.
platform. Okay, yeah, and in those environments, the general purpose, and there's a lot of avenues and protocols and communication capabilities in those platforms,
Yeah.
which opens up Pandora's box per se of opportunities to be impacted.
Hmm.
So it's just the whole the environment. You have to you step back a second. Okay, so this technology is out in manufacturing, given it's old. Old doesn't mean it's bad. It's just it's older, so that's what it is.
Right.
Get your head around that, and then understand that, and then okay, how do we, from a budgeting perspective, how much is the cost? And that's in manufacturing, the IT budget. If you have automation rolled into the IT budget on a manufacturing site, it's typically 50, 60% of the IT
Yeah.
budget is going to be the automation components and piece. I'm like, oh my God,
Yeah.
that's a huge cost. Yes, it
Yeah.
is. It is. So, how do you use that? You're spending money. How do you do it smart
Hmm.
to
So
maintain?
that's a good lead into the next question is like, how prolific is this introduction of smart technology versus two to
Yeah.
three, 5 years ago, whatever the right time frame is? And, what are some examples of kind of how it's been integrated into the
So
automation process?
I've been dealing with smart manufacturing, smart technology for 40 years.
Yeah,
40 years. So like way back to the early days in the 80s, I was at Eastman Kodak Company, and we used some technology, GenSim G2 was one of the first AI engines way back when. Um, and it was very slow. And there's lots of reasons why it was very slow. Lots and lots and lots. And you learn from it. But the early adopters, like you learn from that, like, okay, that sort of worked. We put a heck of a lot of energy and time into it, and took a lot of engineering work to get some value from it. Wasn't really cost effective back
yeah,
then. Rapid forward now. Today, in last, like I said, I'd say about last 5 years is when the inflection point started to really, change. And it's some of it is the technology, some of it is I call it the vertical integration between manufacturing IT down into the production floor. The opening up, adding what they call IoT, right? Industrial sensors, newer
sure.
technology on the edge, down in the production, and that couples with that all that legacy stuff that's down there. Um, and so now you're starting to it's a mismatch. It's starting to get some really smart new sensors down there, but you've got all this existing stuff that you want to be able to get information from. And I use the word information because just collecting those thousands, like the example I gave for the Pfizer biotech suite, thousands of sensors without context, right? Without context to that raw data, it's a I call it Mount Everest of freaking data. It's like, okay, where is something of value in all of this? There is
Yeah,
value in it, but without context to make sense of it. And that's the whole key with like an AI model. It needs context. You give all the data, that's kind of useless. It takes a lot of work to build them up
right.
from uncategorized information.
Hmm.
So, the key is we got a key ramp, right? We have a very key ramp.
Right.
But when I say key ramp, we're taking advantage of about 20% of the mountain.
Hmm.
Why do I say 20%? 20% is usable. 20% is you can get to it, it's on the network, whatever. There's a good 80% of manufacturing data that is still today unusable.
Just lost. Yeah.
Well, untapped. It's still there. It's like
Yeah.
oil on the ground. It's
Right.
there. It's there. You could get to it. It needs that. You need to add context. And adding context to an existing manufacturing can be done. You can do it live. But adding that context does take time. You have to go back in, right? You
Right.
have to go back in and you have to understand what is going on, what is doing, where is the information, what is the context I need? What do I need to add on this to make sense of it? You know, simple one is like, what product are we making? What product are we making on this production area today or next week or 6 months from now? Okay, now those data sets I want to be able to compare. Right. Yeah, it makes sense. Well, I don't
Right.
have in the real-time data, what product's being made, that's irrelevant to some degree. Obviously there's a setup of information that tells the manufacturing what to make, but it's just the point being is you have to add a bunch of context. That's just one parameters. You need like 10, maybe 20 sets of data that add context and the keys to all that information to unlock it to get
Hmm.
value out, and then you can send that data with context and raw data together up into an AI engine and crunch away and build a manufacturing model of what's
Right.
happening. And then you can use the model down in manufacturing, on a day-to-day basis in real time and get value from it. So it's so cybersecurity around all that. So smart technology is great. It's moving. It's coming together. All the pieces are sort of there, but there's some heavy lifting that needs to be done down in
Yeah.
and it's being done. And it's being done, where the bigger, I call it the better rich oil is in manufacturing. But
Hmm.
we're coming around to, you know, to do that. So
So what are the some of the big cybersecurity challenges that this is introducing? I mean, there have to be some new exposures or some new
yeah,
risk introduced here.
yeah, that's really the challenge is, unfortunately, the challenge is way back when we didn't worry about cyber too much. Um, there was a plethora of technology that was put in that was using, I call it the spaghetti mess of IT networks, in that a flat network, everything's on that. Your mail system, your email system, people
Sure.
are on that, printers are on that, manufacturing's on that network. That it's all shared, right? All those wires are going into a common switch. I was like,
Hmm.
God. So when I say, oh my God, it's like, how are you going to protect a spaghetti mess of data streams? It's a mess. So, an effort, one of the big efforts we did at Pfizer, because Pfizer is a conglomeration of like 45 companies. So you're picking up companies, some of them come in with the spaghetti mess, and you got to clean that up.
Yeah.
You need to at least separate in three buckets. The way I call it, enterprise systems, email people, yeah, that's one bucket. Manufacturing IT, supporting systems, supporting technology, labs, whatever, analytical instruments, fine. They're supporting. And then there's the crown jewels. What's running and making manufacturing? Your real-time, systems that are you need second by second, right? Those are three buckets. And you want to obviously protect the crown jewels, right? You want to put a little more fences and a little more structure around that. Make sure that
Right.
the crown jewels don't get stolen, don't get, don't get impacted.
Yeah.
I mean, that's a big part of it. That's probably the biggest challenge. Is they used to call it defense in depth. Yeah. Well, just separating out the spaghetti piles into three
Right.
is a bit it will help out greatly. Then you got to deal with again legacy technology. Yeah.
Sure.
You got budget constraints. Yeah, we understand
Yeah.
that. Um, yeah,
And I
those
mean,
are the challenges. And here's the other big one in automation technology that my friends in IT used to give me a hard time about. It's like, Jim, why can't you standardize? I'm like, what? We
good
can,
luck.
yeah, wait a minute. You just said standardize. We're 45 companies. And you're going to say, oh yeah, just standardize. Pick a certain technology or a certain vendor and just put it everywhere. First off, there is no vendor out there that does it all for everything in the automated world. There isn't. Like, there's no one, and there's especially no one any to cover the globe. They're all good in their regional areas, and one's better than another. And from a support and structure and supply, there is no standard.
Right.
One company you can go to and say, hey, take care of my problem. No, if you're a global company, international global company, like you're going to be dealing with a plethora of technologies,
Yeah.
systems, components, and this you could say the decision making isn't always mine to make, right? From automation. Sometimes it's from a engineering firm, sometimes it's the manufacturer of a manufacturing line comes with their proven technology and it's coming, you're buying it. It's going to come with, you know, some suppliers specialized equipment.
Hmm.
What happens is you got IT is all great, it's all standardized, and then you get down to the production floor with real-time systems and devices, and then it just blooms. It's a play.
Right.
It just like, oh my God, right? You're dealing with thousands of varying components and technology. Hopefully you can narrow it down so it's, not thousands, but 10, 20. Uh,
Yeah.
but yeah, you're going to be dealing with a lot of different players and different manufacturers.
Hmm.
That poses obviously an additional problem. It's
So
a bigger problem than you want.
exactly. So let's wrap up with just a final question in terms of maybe what's your best piece of advice to the tech manufacturers and even the industrial and healthcare end users that are dealing with these security challenges? What do they prioritize? What's their approach?
Yeah. Obviously, they need to be testing their current equipment and the prior equipment. Um, right? They need to be testing the equipment from, vulnerabilities that are communicated to them, their own internal labs, checking their equipment, verifying, what those vulnerabilities are. And if there's a known exploit out there, they got to be working to, remedy that as best they can, and then be able to advise, the community, the large community is like, okay, we found these, 6 vulnerabilities and we can fix it and we're going to give you an update, or we can't fix it.
Right.
And here's the bad one. We can't fix it. I'm like, oh, you can throw out what we gave you, 20 years ago and put this in place. And that will take care of the problem. But, or you got to, put some fence around it. And let's go back to that spaghetti mess of networks. How do I put a fence around all of them? Yeah, you don't. So you got to separate out and protect out those technologies, segment them out from the rest of
Hmm.
their, network communication. And they might have to go on an island all by themselves. That might be
Yeah.
the ultimate, solution is like, okay, we gotta, oh God, what do we do? Well,
Yeah.
yeah,
That's like the go-to compensating control most of the time, I would imagine.
correct, correct. It's like,
Right.
okay. But if you put 3 or 4 layers and you put some, cost-effective technologies to be able to understand what's going on and protect the environments, you're in a pretty good place. I didn't
Yeah.
say perfect place. You're in a pretty place. You can sleep pretty well.
There's no perfect.
There is no perfect. Unfortunately not.
Right.
There's some really good technologies out there today. I have to admit, over 5 years ago, we did a very large global program in Pfizer. 5, 7 years ago now. And it was a struggle, right? At that time, clarity was just coming, you know, coming
Hmm.
being. And, clarity is pretty new even back then. And yeah, it's like putting that all together and hitting all the needs that we had to, secure. It was a challenge.
Yeah.
Challenge. And we did well. I have to say, looking back on it all, we did very well at Pfizer. Um, but this, doesn't end, right? You have to keep,
Right.
you
It's
have
continuous.
to
Absolutely.
understand it's like, people with AI. So here's the point. AI is a great technology. AI is also a great technology for the cyber attackers as well,
Hmm.
right? So
Yeah.
they can automate things now with these tools to really be, it's kind of scary. So
Yeah.
I have to say, get on the front of this. Use AI now to your advantage because what's coming ain't going to be pretty.
Yeah. I mean, they're finding bugs quicker than ever. They're going to build exploits quicker than ever before you know it.
Correct. The
All right, Jim.
speed of leverage is going to increase. Yeah.
Absolutely. All
Yes.
right, Jim, thank you so much. Great stuff. And it was really good to see you. Appreciate it.
Always good to see you, Mike,
All
and
right.
enjoy life.
Thank you. Take care.
Take care. Bye bye.